Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
For today's lesson, I'm going to teach you about integration. For your information, in A2 syllabus, there are a lot of different types of integration that you need to know. So for today, I'm going to focus on this type, the integration of rational functions. Have a look at this box here. This formula is actually provided in the formula list. So when you integrate a fraction in this form, where the upper part is what you differentiate from the bottom, then you can straight away just ln the bottom part. How to get this formula is actually from the differentiation that you have learned in the previous chapter. Remember how you differentiate a ln function? When you differentiate a ln function, the original fx should be placed at the bottom. Then when you differentiate the bottom part here, then you put it on top. So when you have something in this form, now the other way around, the reverse process, when you integrate something in this form, this fraction, then you should get ln fx. That's how they got this formula. So you need to make sure how to utilize this formula. So for example, if you need to integrate a fraction in this form, 1 over x plus 1 dx. So you have to recognize this fraction as something that you can integrate by using ln. So have a look here. The bottom part should be fx according to the formula. Then the upper part should be f prime x. So I'll name the upper part as f prime x. Let's compare. If you differentiate the bottom part, differentiate x, you should get a 1. Differentiate 1, you get a 0. So this fraction is already the same form as this, which means we can integrate this fraction by just ln the bottom part, ln fx, which is x plus 1. And if there's no limit given, then you need to add a c at the back there. And one question here, why is there a modulus here? It's because we cannot ln a negative value. So later on, if there is a limit for you to sub in case after you sub in the limit, the number here becomes a negative value, you have to modulus it and make it a positive value. Alright? So that's how we make use of this formula. And some student will ask, why is it we can't use the formula that we have learned in AS, the simple integration? Alright, let's try the AS method in solving this question. So by using the AS method, what we do is we will bring the x plus 1 up so that it can have a power of negative 1. Alright, so by using the AS method, we will have this, the n plus 1, which means the power, you got a plus 1. We have a 0 here. And divided by n plus 1 as well, which is a 0 at the bottom. Can we divide something by a 0? The answer is no, because it's undefined. And therefore, for this question, we can only integrate by using ln and not by using the AS method. Alright, so have a look at the note here. So when you have something in this form, the bottom part is fx. The upper part should be f prime x. So if you differentiate the bottom, you should have an a at the upper part. But what we have here is a 1, and therefore we need to make some adjustment. So let me copy back the question. Alright, so now differentiate bottom, I should have an a. So I add in the a here. But if I add in the constant a, I'll be changing the question. The original question is just 1 there. So since we multiplied with the a, then we have to divide by the a outside here. so that the A and the A here can be cancelled off and it's back to the original question. So the 1 over A here is the adjustment that I have made, and therefore the 1 over A, I'll keep it here. And this fraction, if you compare to this formula, they are in the correct form, and therefore I can just ln the fx. So for this case, we can just ln ax plus b. That's how we get this general formula. Let's try to solve these questions by using the formula that we have just learned. Have a look at the part A. You're asked to integrate 1 over 3x plus 4. So you have to recognize this fraction as the type that you can integrate by using ln. So the bottom part should be fx. The upper part should be f prime x. So the first thing that you need to do is try to differentiate the bottom. So when you differentiate 3x plus 4, we should have a 3. So I'll add in the 3 here, but this will change the question. The original question is 1 over 3x plus 4. So when we multiply with a 3, then we should adjust by having a 1 over 3 out here, so that this 3 and this 3, when it cancel off, you will still get back the original question here. So the 1 over 3 is the adjustment that we have made. So the 1 over 3 will just stay here, and we can just straight away ln the bottom part, which is 3x plus 4. Okay, let's try the B. You are asked to integrate 1 over 1 minus 2x. So bottom part should be your fx, the upper part should be f prime x. So differentiate bottom, you should get a negative 2. So I'll just add in the negative 2 here and divide by a negative 2 outside. So the adjustment that I have made is negative 1 over 2. And you just need to ln the bottom part of the fraction. Let's continue with part C. Part C, you are asked to integrate 3 over 5x plus 2. Have a look at this fraction. When you differentiate the bottom part, 5x plus 2, you're supposed to get a 5 on top. But what we're having now is a 3. So what we do is, you just need to take out the 3. So you'll be left with 1 over 5x plus 2. Now only we start making the adjustment. So when you differentiate the bottom 5x plus 2, we should have a 5 here. So when you have multiplied with a 5, the outside here you're going to divide by a 5. And therefore the adjustment that we have made is 3 over 5. And ln the bottom part of the fraction, 5x plus 2. Have a look at the part D. D, you are asked to integrate x over 2x squared plus 3 dx. Alright, so check for the bottom part. When you differentiate the bottom part, we should have 4x. And there's an x here. So what we need to add in is just a number 4. And I have to divide by the 4 outside here. And take note, we can only make adjustments by using constants. We cannot simply add in or take out any variables like x. We can only make adjustment by using constants. So for this question, the answer should be 1 over 4 ln 2x squared plus 3n plus c. That's how we recognize the function as a function where we can integrate by using ln. These are just some simple examples. But sometimes you will see some special cases like where you need to integrate tangent and cotangent. So when you integrate tangent and cotangent, the method is actually the same. The tangent, you will just need to split it into sine x over cos x. then it becomes a fraction. Then take note, for the bottom part it should be fx and the upper part should be f prime x. So let's try to differentiate cos x. Differentiate cos x, you should have negative sine x. So I need to add in a negative here and balance it by a negative outside. And therefore, the answer is negative ln the bottom part of the fraction, which is cos x. That's how we integrate tangent. And what about cotangent? Integrate cotangent 2x. The method is actually the same. You just need to express the cotangent in a fraction. So cotangent 2x is equals to cos 2x over sine 2x. And now let's try to differentiate the bottom part, sine 2x. So when you differentiate sine 2x, you should have 2 times cos 2x. So we will need to add in a 2 here and divide by a 2 outside. And therefore the adjustment that I have made is 1 over 2 and ln the bottom part of the fraction, which is sine 2x. This is how we integrate tangent and cotangent. Let's have a look at this past year question and see how we can apply the method that we have learned earlier in solving this question. So have a look at this May-June 2017 paper, variance 33. So for the part 1, you are supposed to express the function in partial fractions. So for this, I'm not going to explain it today because I've actually taught you in the other video. We will just straight away proceed to the second part. But before that, I'll need the answer from the part 1. So I'll just copy the answer here. Okay, so for the part 1's answer, it's 3 over x minus 2 over x squared minus 6 over 3x plus 2. And now we can proceed to the second part. The second part, have a look at the question here. Take note about the word hence. When you see the word hence, means it's related to the previous part. So hence, show that the integration of the function from 1 to 2 is given by this answer. So the answer is already given here. We just need to prove to this answer. So what we need to do here is, instead of integrating the fx here, we should integrate our partial fraction. So I'll just change this into part 2 and integrate the partial fraction from 1 to 2. Now let's start integrating the first term, 3 over x. So you got to recognize this one as the type where you can integrate by using ln, because the x, when you bring up, is x power negative 1. So if you want to apply the AS method, x power negative 1, if you take the negative 1, the power, n plus 1, negative 1 plus 1, it should be equal to 0. So later on, you're going to divide by a 0, which is undefined. So for the first fraction, we can integrate by using the ln. So let's say I'll write it at the side here, integrate 3 over x. What we need to do is differentiate the bottom. So differentiate x, we should get a 1 there. So the extra 3, I'll just take out first and left with 1 over x. So differentiate x, I'll get 1 on top, so it's already in the correct form. Therefore, the answer is just 3 ln the bottom part, which is the x. So I'll substitute this into the first part. Integrate 3 over x is 3 ln x. As for the second term, 2 over x squared, for this one, we can actually integrate by using the AS method, because when you bring up the power, it becomes 2 times x power negative 2. So if you apply the AS method, then you will get negative 2 plus 1 is negative 1 and divided by negative 1. So I'll write this answer to the second term, which is minus negative 2 over x. As for the third term, we are supposed to integrate 6 over 3x plus 2. So what we need to do is recognize this as the type of fraction where you can integrate by using ln. So now when we differentiate bottom 3x plus 2, we should have a 3. But instead we have a 6 up there. So I'll just take out the 6 and it will be left with 1 over 3x plus 2. So now when you differentiate the bottom, you should need to add in the 3. So I'll divide by the 3 outside here, which means the adjustment that I've made is 2 ln the bottom part of the fraction, which is 3x plus 2. So now let's add this into the third term. Minus 2 ln 3x plus 2. That's how we integrate this partial fraction. So during the exam, you can straight away just write down the integration without doing part by part. So now what we need to do is sub in the limits from 1 to 2. So first of all, we need to sub in the number 2 into the x. Then we will get 3 ln 2 plus 1 minus 2 ln 8 minus, substitute the limits of 1 into the x, you get 3 ln 1 plus 2 minus 2 ln 5. And what we are supposed to do now is just simplify the answer to what is requested by the question here. So let's group the constant together. Constant is a 1 and 2. So 1 minus 2 is a negative 1. Then you're just left with all the ln terms. So for the ln terms, according to the question here, there's no coefficient in front of the ln. So all these coefficients I'll just bring up as the power. So 3 ln 2 becomes ln 2 power 3, which is 8, and minus ln the 2 bring up 8 power 2 is 64, and ln 1 here is actually a 0, and the last term negative becomes positive, and the 2 here bring up, it becomes ln 5 power 2 is 25. And the last thing that we need to do is just to combine all the ln. So when it's a minus means divide, plus means multiply, so we will have 8 times 25 over 64. So for here, to simplify this, you can just press the calculator. 8 times 25 over 64. You will get ln 25 over 8, and the constant you will just need to copy back. That's how we show the answer. That's all for the lesson today. Thanks for watching.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.